We are still recapping information from Chemistry 11. This was the math of solutions. You'll have this set of notes and they're already filled in, so it's a matter of just going through, seeing if things make sense. So, asking you for a concentration of solution, if I give you a mass of material, in this case sodium chloride, and I give you a volume, you should be able to work out its molarity or concentration. So we go mass to moles, then we take our moles, we have to have our milliliters and liters, and we get 1.14 m. That should be easy. We should remember that number of moles equals the concentration multiplied by the volume in liters, and that moles are conserved. So C1V1 equals C2V2. So if we increase the volume, we decrease the concentration, or if we decrease the volume, we'll increase the concentration. So here was a sample question. We're taking 50 mils, we're diluting it up to 8 liters, and we want to see what happens to our 4.00 m. Well, we know this is going to go down a long way. Here's our 4.00 m. Here's our initial volume. Our volume's gotten way bigger. Our concentration has to get smaller. When we multiply these two numbers together to end up with our 0.2 moles, those moles are conserved, divided by the 8.00 liters, and we get 0.0250 big M. So here's another one. This is working the reverse. We're going to stock solution, which typically is more concentrated. And so here's our C1V1, and we want to have this concentration is what we're starting with actually. And we want to know the volume we started with before we diluted it down to 500 mils. So we do our C1V1, divide by that, and we see we have 0.00625 liters or 6.25 mils. Dissociation, you should remember that's really easy. Boom, 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 a little stoic. 1 to 1, so they're all the same. In this case, it is 3 to 1, so we triple this, and this stays the same. Boom times 3, boom times 1. So that should be no sweat. When we did the mixing, sometimes we have a common ion, sometimes we don't. In this case, we did have a common ion, the permanganate. And so we have to get our equation, the dissociation equation, get our moles, use our stoich, 1 to 1. Get our moles, use our stoich, 1 to 1. And then we gather the moles, boom, boom, and we have that. And these moles combine together to be 0.0800 moles. We know what our total volume is, has to be in liters. And when we go through, we divide by that total volume, and we get that. And then we get that, and then we get that. So again, this should have been your notes. Here we had permanganate, a common ion, in 2 places. That's why we had to add it before we divided. And here's the same kind of question. There's our volume concentration. Get our moles, boom, times 1, boom times 3, boom times 1, boom times 2. Gather these moles, take these moles, and divide them by our total volume, and it was a nice convenient number. So we're dividing by 1/10 of a liter, and we get those concentrations. So that's a quick recap. Of course, you can pause this if you want to make it longer, but that's stuff you should know by now, and if you don't, go back and make sure you're on top of it.